Welcome back, everybody. Today, we're going to be taking a deep dive into a pretty fascinating subject, sagas. They're a pattern that is super important when you're dealing with transactions in a microservices architecture. So, imagine like you're building an app and you've got to coordinate actions across different services, and each of those services has its own database. How do you make sure that everything stays consistent, even when things go wrong?
Yeah, that's a great question. And this is exactly where the Saga pattern comes in. I've actually implemented sagas in the real world, and I can tell you firsthand, it's really essential when you can't rely on traditional ACD transactions, especially when those transactions have to span multiple services.
Okay, so that's a great intro, but can we take a step back for a second? What is a saga?
So basically, a saga is a sequence of local transactions. Each of those local transactions is happening within its own service and its own database. And each transaction, it does its part, and then it triggers the next one in the
It's
sequence.
kind of like a chain reaction.
Yeah,
So,
exactly.
yeah.
Like a chain reaction.
Okay, I like that. So it's like a really carefully choreographed workflow. But instead of dancers, we've got these individual transactions.
I like that analogy. Yeah, you can think of it that way. But there's another really important characteristic of sagas, and that's this idea of compensation. So you see, we don't have that luxury of being able to roll back everything automatically like you would in an ACD transaction.
Right.
So to kind of work around that, every step in a saga actually has a corresponding undo action. And this undo action is called a compensating transaction.
Oh, okay. So it's kind of like having an undo button for each step of the process.
Exactly, like an undo button. And this is really important because in these distributed systems, things will go wrong. A service might be down, a network connection might fail, you might have a business rule violation pop up. You've got to be ready for anything.
Absolutely.
So, let's say a customer tries to place an order, but their credit limit check fails after the order's already been created. With a saga, the system would be able to trigger those compensating transactions. It would undo all those previous steps, like releasing any reserved inventory and canceling the order.
So it's all about making sure that even if one part of the process fails, we can still keep the entire system in a consistent state.
Precisely. You said it perfectly. It's all about gracefully handling those inevitable hiccups that come up in a distributed environment.
That makes a lot of sense. So I think I'm starting to get the big picture here. But could we maybe walk through a more specific example just so I can really see how a saga works in action?
Of course. Let's use that e-commerce scenario that you mentioned earlier.
Perfect. Yeah. So let's say a customer places an order on our platform.
Okay, so the first thing that happens is the order service receives the request. It creates the order in the database, but it initially marks it as pending. And then it publishes an order created event to signal that it's time for the next step.
So it's like it's telling all the other services, hey, we've got a new order here, time to get to work.
Exactly, you got it. So now the customer service is listening for this event, and as soon as it hears it, it jumps into action. It checks the customer's credit limit. And if everything looks good, it reserves the necessary credit. And then it publishes its own event, let's say a credit reserved event, to let all the other services know what happened.
So it's like each service is passing a baton to the next one after it finishes its task.
Yeah, like a relay race. I like that.
Okay, so what happens next?
Well, now the inventory service comes into the picture. Once it receives that credit reserved event, it checks to see if all the requested items are in stock. And if they are, it reserves them. And then it publishes, you guessed it, an inventory reserved event.
Wow, so many moving parts.
Haha, it seems like a lot, but it all works together seamlessly.
Right, so the customer service has reserved the credit, the inventory service has reserved the inventory. What happens now?
Well, the order service has been waiting for those two events. Now that it's received both of them, it knows that it's safe to go ahead and mark that order as approved. And then it kicks off the shipping process.
Awesome, and if anything had gone wrong along the way, we'd have those compensating transactions to roll everything back.
Exactly, you got it.
So even though we have all these different services working together, the saga ensures that the order process either fully completes or it gets cleanly reversed if any step fails.
You got it. That's the beauty of sagas.
This is making so much more sense to me now. But before we move on, I'm just curious. Is this like event-driven communication the only way to coordinate sagas?
That's a great question. And it actually isn't. There's another approach called orchestration. And in this approach, there's a central component that directs each service, kind of like a conductor leading an orchestra.
Oh, interesting. So like two totally different ways to approach it.
Yeah. Exactly. We can dive deeper into the differences and the pros and cons of each approach a little bit later.
Yeah, I'd love to learn more about that. I'm really curious to see how those different styles of coordination play out in practice.
Sounds good. All right, so let's get back to those two different approaches for coordinating sagas that we talked about. Choreography and orchestration. Remember how earlier we were comparing them to a dance performance versus like an orchestra with a conductor?
Yeah, I remember. That was a really helpful analogy.
Perfect. So with choreography, each service is kind of like a dancer in a really well coordinated routine. They all know their part and they react to cues from the other dancers. But in our case, those cues are the events that are being published by the other services.
Okay, so there isn't one single director calling all the shots. Each
Oh.
service has its own logic for how it's going to respond to these events.
Exactly. It's a much more decentralized approach, which can be really elegant, especially for simpler workflows. You can think of it kind of like a chain reaction. One service takes an action, publishes an event, and that triggers the next service, and so on and so forth.
Okay, that sounds pretty straightforward. But I can imagine that things could get pretty complicated if you have a ton of services all interacting with each other. It'd be like trying to coordinate a dance with hundreds of people.
Yeah, you're exactly right. Choreography can definitely become really challenging to manage as the complexity grows. You might end up with this really tangled web of dependencies, and it can make it really hard to understand the overall flow of the saga. And then, if something goes wrong, forget about it. It can be a nightmare to try and troubleshoot.
Okay, so that's where the orchestra, or I guess orchestration, comes in.
Exactly. With orchestration, we have a central conductor. It's called the Saga orchestrator. And this component acts like a director. It tells each service exactly what to do and when to do it, and makes sure that everything happens in the right order.
So it's like having a project manager overseeing the whole saga and making sure that everybody stays on track.
Yeah, that's another great analogy. So the orchestrator sends commands to each service, things like, you know, reserve credit or ship order, and then it waits for a response from each service before moving on to the next step in the saga.
Okay, so it sounds like that would give you a lot more visibility into the whole process. Like if something goes wrong, you know exactly where to look.
Exactly. You're thinking like a true software architect. And yeah, it definitely makes error handling and recovery a whole lot easier. The orchestrator can handle things like retrying failed steps
Yeah.
or triggering those compensating transactions that we talked about before. And it can do all of that in a much more controlled way.
Okay, so it seems like orchestration gives you more control and maybe even better consistency guarantees. But I'm guessing that it also comes with its own set of trade-offs.
Of course, there's no such thing as a free lunch, right? The main trade-off with orchestration is that you're introducing a single point of failure with the orchestrator. Like if that orchestrator goes down, the whole saga could come to a screeching halt.
That's a good point.
Hmm.
So you'd need to make sure that the orchestrator itself was super resilient, maybe with some redundancy or failover mechanisms built in.
Exactly. You're thinking ahead, which is good. You also need to consider the added complexity of building and maintaining the orchestrator itself. It's just, it's another component in your system that you have to manage.
Right, so choosing between choreography and orchestration is really about carefully weighing those trade-offs, right?
Exactly. There's no one-size-fits-all solution here. It really depends on the specific needs of your application.
So if you have a relatively simple saga with just a handful of services, choreography might be the best choice.
Yeah, it would be a lot more lightweight, easier to implement,
Right.
and you'd avoid all that overhead that comes with a central orchestrator.
But if you're dealing with a really complex system with tons of services and all sorts of complicated workflows, orchestration might be the better option.
Exactly. Even though it adds some complexity, the control and visibility that it gives you can be super valuable in those situations.
Okay, awesome. That definitely clarifies things a lot. So we've talked a lot about the benefits of sagas, but now I'm kind of curious about some of the potential challenges that developers might face when they're actually implementing sagas.
Mhm.
Like, for example, the source material that we looked at mentioned this lack of automatic rollback.
Yeah.
And it also talked about the risk of data inconsistencies. Could you maybe shed some light on those concerns?
Yeah, absolutely. Those are definitely some critical aspects to keep in mind when you're working with sagas. We can dig into those challenges in the next part of our deep dive.
Also, we've talked about the two main ways to coordinate sagas, choreography and orchestration. But now I want to get into some of the trickier parts.
Yeah.
Like the source material that we were looking at mentioned that sagas don't have automatic rollback. That sounds pretty different from those ACD transactions that we're used to, where everything just gets neatly reversed if something goes wrong.
Yeah.
So how do developers handle that with sagas?
Yeah. That's definitely a key difference to keep in mind. With sagas, you're essentially building your own rollback mechanism, and you're doing that through those compensating transactions that we talked about before.
Oh, okay, so it's a lot more manual. Like for every step in the saga, the developer has to think about what needs to happen to undo it if a later step fails.
Yeah, exactly. It definitely requires some careful planning and design up front. You need to think about all the potential points of failure and make sure that you have compensating transactions in place to handle all of them.
Yeah,
Okay,
okay, that makes sense. Can you give me like a specific example of what a compensating transaction might look like?
sure. Let's go back to that e-commerce example that we've been talking about. Remember how the customer service reserves credit for an order?
Yeah,
The compensating transaction for that step would be to release that reserved credit. Like, let's say if the inventory reservation fails later on, or, let's say the order service had already marked the order as shipping. The compensating transaction in that case might involve updating the order status back to pending and then, notifying the shipping service to cancel the shipment.
yeah. So it's like having an undo button for each step in the saga. But it's up to the developer to define exactly what that undo action should be.
Exactly. That's a great way to think about it. And this is where things can get a little tricky because you really need to think through all of the possible scenarios and you need to make sure that your compensating transactions can handle all of those edge cases.
Right, that makes sense. What about that other concern that the source material mentioned?
Yeah.
The risk of data inconsistencies. Because sagas don't have isolation.
Right. That's another really important point. So, unlike ACD transactions, which guarantee isolation, sagas can actually run concurrently. And that can sometimes lead to some unexpected results, especially if two sagas are trying to operate on the same data at the same time.
Hmm. I'm not sure I totally understand how that could lead to inconsistencies. Could you maybe give me an example?
Yeah. Sure. So imagine that we have two sagas running at the same time, and they're both trying to update the same customer's credit limit.
Okay.
So Saga A checks the credit limit and sees that there's enough available balance. But before Saga A can reserve the credit, Saga B comes along. And Saga B also checks the credit limit, which still looks good at that point. And then Saga B goes ahead and reserves the credit.
Oh.
So now when Saga A tries to reserve the credit, it might accidentally overdraw the customer's account.
Yikes. Okay, yeah, that's definitely a problem. So
Mhm.
how do developers prevent those kinds of conflicts from happening?
Well, there are a few different techniques that they can use. One common approach is something called optimistic locking. And basically, this involves storing a version number along with the data.
Okay.
And then each time the data is updated, that version number gets incremented.
Okay.
So if Saga tries to update the data using a stale version number, the update gets rejected. And that prevents any inconsistencies from happening.
So it's like a built-in check to make sure that no saga is operating on outdated information.
Exactly. It's a really clever way to handle concurrency. Another approach is to just design the sagas themselves in a way that minimizes concurrent access to the same data.
Right.
Like, for example, you could try to segregate the data by customer ID or order ID
I
so that each saga is only ever working with its own little slice of the data.
Okay, that makes sense. What about like the actual mechanics of how a service updates its database and then publishes an event to trigger the next step in the saga? I'm guessing we can't really rely on traditional distributed transactions here, right?
Yeah, you're right. Distributed transactions are often not a great option in a microservices environment. They can be really slow and unreliable.
Okay, so how do developers make sure that those database updates and event publications happen in a consistent way?
Well, there are a couple of patterns that can help with that. One is called event sourcing. And with this pattern, you're essentially storing every single change to your data as an event. And this makes it super easy to rebuild the current state of your data at any point in time. And it also gives you a really nice audit trail of all the changes that have happened.
Oh, that's cool. So it's like keeping a detailed log of everything that's happening within the system.
Exactly. You
Yeah.
got it. And then the other pattern is called transactional outbox. And with this one, you're using a separate database table to store all the events that need to be published. And the cool thing is that the database update and the insertion into that outbox table, they both happen within the same transaction.
Okay,
So that ensures that they either both succeed or they both fail.
got it. So those patterns help keep things consistent within a single service. But what about like the bigger picture? How does the client that actually initiated the saga know what's going on? Like it could take a while for the entire saga to finish right.
Yeah, that's a great point. The asynchronous nature of sagas can definitely make client communication a little bit more challenging.
Right.
There are a few different options, though.
Like the service could send back a response to the client once the entire saga is complete. or the client could poll for the result periodically. Or you could even use WebSockets or webhooks to push updates to the client asynchronously. So there are a bunch of different approaches that you can use to keep the client informed. It really just depends on the specific needs of the application.
Exactly. You nailed it.
Wow, we've covered a ton of ground today. We talked about the basic concept of sagas. We went through some pretty intricate implementation details. Do you have any final thoughts for our listeners before we wrap things up?
I think the main takeaway is that sagas are a super powerful tool, especially for managing transactions in a microservices world. But they definitely come with their own set of complexities. So it's important to choose the right coordination mechanism for your needs, choreography or orchestration. And you also need to make sure that you're carefully designing those compensating transactions and thinking about how you're going to handle that lack of isolation.
Those are all really great points. I've included links to all resources that we mentioned today, plus some additional reading in the show notes for anyone who wants to learn more. And I want to leave you with one final thought to ponder. The source material that we're looking at briefly mentioned a pattern called command-side replica, and it basically suggests
Mhm.
that you can sometimes query data instead of having to use steps in a saga to get information. So I'm curious, could this be a game changer? Could it potentially simplify the way that we design sagas in the future? It's something to think about as you continue on your microservices journey. Thanks for joining us on this deep dive into sagas. Until next time, happy coding, everybody.